Hello everyone, this is Vinay Kumar from Sri Venkateshwara College of Engineering. Today I am here to explain a topic in mathematics that is about joint probability distribution. So, what is a joint probability distribution? Given two random variables that are defined on the same probability space, the joint probability distribution is corresponding probability distribution on all possible pairs of output. The joint distribution can just as well be considered for any given number of random two variables. This is the introduction about the joint probability. What happens when we have two or more random variables? So let's explore the concept of joint probability and how it helps us understanding the likelihood of multiple events occurring together in the joint probability distribution. So calculating the joint probabilities. Let's roll up our sleeves and get into the nitty-gritty of calculating joint probabilities. We'll explore the formulas and method to determine the likelihood of specific combination of events. So, a joint probability distribution represents a responsibility distribution of two or more random variables instead of event big labeled A and B, that is nothing but A union B. For example, P of A union B, that is f of x comma y is equal to P of x is equal to x and y is equal to y. Discovery how marginal distributions can provide insight into individual variables within a joint probability distribution. It's like zooming into the see the details within the big pictures. This is the power of marginal distributions. For example, here are some examples of the joint distribution random variables. They are the time you have to repeat yourself on the phone and your single reception, the grade you receive in an exam and the amount of sleep you have had the night before is the sum of the examples of the joint distributions. Visualizing joint probability. From scatter plots to counter plots, we'll explore how to visualize the relationship between the variables. These are the some of the pictures that are visualizing the joint probability. Let's bring the number of life with visual representation of joint probability. So why do we need the joint distribution encodes the marginal distribution, that is, the distributions of each of the individual random variable and the conditional probability distributions, which deals with how the outputs of random variable are distributed when given information on the output of the other random variables. Real world applications. We'll explore particular example and see how understanding joint probability can help make informed decisions in various fields. So some of the real world examples are, for a deck of cards, the probability that you get a 6 given that you draw a red card is P6 red is equal to 2 by 26, so that is 3 by 13. Since there are two sixes out of 26 red cards. Statisticians and analysts use joint probability as a tool when two or more observable events can occur simultaneously. This is one of the example cards are the one of the example for real world application in the joint probability distribution. Challenges and limitations. While joint probability distribution is a powerful tool, it's not without its challenges and limitations. Let's explore the potential pitfalls and considerations when working with the joint probability distributions. So, what are the challenges? For example, there are six sides to each one. In order to determine the joint probability, we first need to determine the probability of each roll. The chances of rolling a 3 on the first die is 1 by 6. The chances of rolling a 3 on the die is 1 by 6. This is the sum of the limitations of the joint probability distribution. Wrap up and so as we consider our probability pods, let's be the joint probability distribution. Remember, the probability can be a fun and full of surprises. Finally, joint probability means the probability that two or more things that are not connected to each other will happen at the same time. For example, the probability that two dice rolled together will both land on 6 is a joint probability scenario. This is about the joint probability distribution. Thank you.